Good morning, ladies and gentlemen. Welcome to our Thought Leadership series of webinars. Digital Enterprise, Performance Testing on the Cloud. This is a Thought Leadership series by TenXLabs, a pure-play software testing services company for the new age digital enterprises. With over 800 plus ISTQB certified test engineers, TenXLabs has successfully completed over 150 complex projects across the globe. I'm Imran, your host for the morning, and I have with me Suchita Ahuja, who's our Senior Performance Test Architect and a thought leader in performance testing domain. Suchita is an expert on both open source and commercial tools and has successfully delivered end-to-end performance testing solutions for large digital enterprises. Suchita today will enlighten us on how digital enterprises can shape their performance strategies by leveraging the cloud. So without further ado, I welcome Suchita. Thank you.
Thank you, Imran. Hello everyone and welcome to the Thought Leadership Talk on Performance Testing on the Cloud. Here in this talk, we'll look at performance testing in general, introduce the concept of cloud. We'll also see how it is important for organizations to test their applications on performance. We look at a few other limitations of having performance testing run on the cloud as well as on the on-premises systems, and how cloud provides some alternatives to overcome the limitations of on-premises infrastructures. Towards the end, we will also have a look at how we perform performance testing over the cloud by just simply uploading the test scripts and initiating the executions on cloud-enabled solutions. So, performance, as the term suggests, is an attribute of a system to be able to work with stability and quickness when it is used under some conditions. Therefore, in the software world, performance testing is a kind of quality assurance activity that emphasizes on evaluating the application on some non-functional aspects such as responsiveness, scalability, behavior over a long-term usage, etc. So as quality people or as organizations with focus on quality, we have established strong processes and checks on software and applications before we open them up in the market, in the real world. We try to thoroughly ensure that the application is performing what it is expected to perform in terms of its functionality, results, data transfers, transactions, look and feel, etc. Now, imagine a situation where we have launched a thoroughly tested and quality assured website or an application. This was checked on all basic things, but when it came to the market, it was used by supposedly 100 users simultaneously. Almost 10 of them could not complete their transaction. Now, a few minutes later, a few of them had a very hard time seeing anything on the screen. And say another few minutes later, the browser said the service is unavailable and the transactions were lost. Now, just think which aspect of quality process would you blame this on actually. We said we had a strong QA process. We had testing experts. We had extensive test case suites. We tested on many builds repeatedly. We did lots of regression, and there was 100% test completion. There was no defects open when we launched. But there was certainly some aspect that remained untested and that blew out of proportion when the real world saw the application. So imagine how much loss it would have given to the company. It would have lost on the customer loyalty, in its brand name, its revenue. It's a big loss certainly. So this aspect that we're talking about here is the concept of availability and usability of the application. When its usage, under the conditions when the usage is matching the usage that it will be subjected to in a live environment. Which means we did not check the performance under the situation when many people were concurrently accessing the application. So probably a couple of decades earlier, not performing such kind of a test would have gone unnoticed because of many of the applications in the usage in the real world. The usage was not way beyond the usage that they were subjected to testing before the launch. The hardware and configurations that were used to host the applications in productions were almost able to accommodate or scale up according to the user base scaling up. However, recently the world is becoming more technology enlightened. More and more people are working online and with applications to drive even simplest of their tasks like booking movie tickets, booking cars on rent, shopping online, getting groceries, checking their children's homework online, and most commonly they are becoming socially active on so many online forums. There is so much of education happening online in virtual classrooms. So we know the size of user base waiting to attack the application when it is launched is very big and obvious. It is obvious to make this as a precondition in the testing environment, where the application is tested on its estimated user load or the anticipated user load. In comparison to functional tests, where the focus is on validating against the functional requirements, here in this type of a testing, the focus is to validate the application on subjective aspects which are driven from customer satisfaction, and also on some numerical aspects which are again driven from market research, or in case there are previous baselining on responsiveness and all available, they can be used as references. So the slide here that you are seeing, this is talking about the importance of performance testing with all the concepts that we have just discussed. Another very important aspect why performance testing is important is uh, organizations might be doing projection of their expected user base. Supposing this year an organization had 50,000 users accessing the site. Next year they are expecting it to go to 60,000, and they want to project what kind of a hardware scale up they should be investing in. So if we know the performance benchmark figures and if we know this much of a configuration would support these many users, we can approximately generalize or maybe prorate, not exactly in terms of numbers, but we can in general prorate and suggest that this kind of a scale up will be required to support an additional number of resources, additional number of users. And other than that, other than the aspects which are visible to the end user like response time and availability of the application, there are other concepts like leakages in memory and other resources which applications are using. While performance tests are being performed, these resources also can be monitored. So this is another aspect at the server level that performance tests help in checking. So different organizations, they have a different indicator of application performance based on how their application will be used. Some organization might just want to look at the response time when there is significant load on the server, and they just want to test whether all the transactions would reach to completion and what kind of a response time the user would see. Some other type of applications might want to stress the server with a very high load or a resource crunch. So this kind of a testing will be called a stress test. They might want to know that the load at which the application will begin to degrade significantly to the extent that its response time would become kind of uninteresting to the user, and he might even choose to leave the site and go and choose to go to some other site, and he might not return. So that point in the load will be called the break point of the application in terms of load. So some other organizations might be interested in performing a longevity test. Longevity test is a kind of test where we keep the application running for a very long duration under some pre-decided load, concurrent load, say 4 to 5 days or even 10 days. And in such situation, we see that what kind of memory bottlenecks are observed, handle leaks are observed, those kind of things are observed in this kind of a test. Based on these areas of interest, different kind of testing or different flavors of performance testing are picked up by organizations. So there is a kind of testing called volume testing, wherein we work with a very big database. The database is very, very heavy. Does it actually impact the performance or the behavior of the application as it appears to the end user? Similarly, scalability testing would aim to determine the software application's effectiveness in scaling up to support when there is an increase in the user load. It helps in planning the capacity, again, like forecasting of the infrastructure. So this is how the organizations would decide on their flavor of testing based on their need. Having said that, a typical performance testing workflow that almost every tool and every process follow looks like something that you see on the screen. It's like there are many tools available in the market that facilitate this execution. Uh, what happens in the beginning is that important business critical workflows on the applications under test, or most frequently used business scenarios that are expected to see more and more of user activity are identified, and they are captured in a tool like recorded sequence that can be played back repeatedly. Most of the tools support this kind of a recording, but otherwise there are frameworks also that help us to use the APIs and code this kind of a mimicry. So this mimic of a business activity on the application is customized and made capable to generically run with other users in terms of variables like session IDs, user IDs, and other dynamic user-related information. Maybe cookies are handled here, and so many other points like this. Such a coded workflow that can be played back. This is called a web script, web test script, or a web test. A web test is subject to constraints. The next step is the next step of executing a load test. A web test is different from a load test. Web test is just a mimicry of some actions. It is a simulation of action from a browser-related thing, but not actual browsers. A load test is, however, a set of constraints applied on a web test. So a web test is subject to constraints and conditions like concurrent user load, maybe of 100 users, execution duration, maybe say 1 hour, target servers where it will be executed, the network that it will utilize, the browser that it will use to simulate load and all. And these are executed for a specified time. Now, all of this situation that is created around a web test, that together forms, in totality, it forms a load test. This load test can be a singular load test, or it can be a mixture of some activities that users are will actually try to perform on the application. This test is executed, and while this test is being executed, the tool, whichever we are using, tool or some peripheral aids like we have Perfmon in Windows, and so many other things are there for monitoring sake. They help in capturing what is happening to the hosting environment. While the load test is running, there is a capturing and monitoring happening in the background, and it monitors the processor utilization, memory consumption, server responsiveness, and so many related factors which can be specific to the server that is hosting the site, which may be specific to the database which is hosting our data, and any other resources that are playing some role in the application and that might be subject to some kind of a throttle activity or a bottleneck, and might pose some danger to the application performance in general. So at the end of such an execution, such a test, other averages like maximums and minimums, averages, maximum, minimums are captured and published as performance figures. So in case this is a first time activity, these can become the benchmarks for every subsequent performance activity, and we can see whether the next execution on a different build has led to a degradation in the performance, or it has led to an upgradation in the performance, and things like that. And in such reports, we can establish performance trends by repeated execution of similar or different kinds of various other workflows in the application. So you see, there is a strong analogy between the way you would execute a functional test and the way you would execute a performance test. The only difference being, in our functional test, we know what to test against. We know what is the expected behavior. In performance testing, the expected behaviors are a little bit ambiguous, little bit in the gray areas. The values are not very defined to the minutest levels. They are a little bit approximations, but then yes, even if we are able to meet the approximations, we can certainly comment on the performance of an application and how it is going to behave in the real world. So as I mentioned, there is this list of tools which support this kind of an activity of recording and playing back and user load simulation. We have open source tools like JMeter. There are so many other tools, proprietary tools like Microsoft PSTS, WebLoad, and all. So all these have the capability in general to support this kind of performance testing, recording, playback, and capturing. So moving forward, let's talk a little bit on cloud, and then we'll talk about performance testing and cloud together. Cloud computing as a concept, cloud computing is defined as a computing that relies on sharing of computing resources rather than just depending on some local servers or personal devices to handle applications. Cloud computing is comparable to a grid kind of a computing where the unused processing cycles of all the processors available on the network, they are harnessed by a cloud service provider and they are provisioned to somebody who actually needs the cycles. So they are so much in use to solve problems that are too intensive to solve for any standalone machine. Many processors can group together, can come together to solve a processor need that may be very, very big to be solved by a single standalone machine. So essentially, it is a concept of systems, infrastructures, and software that are being dynamically available to users in real time while being present on virtual machines located somewhere on the network on the globe that we are not aware of. There are multiple data centers existing across the globe on the network which are provisioned on demand basis immediately as soon as there is a request or a demand from the user. So it is a network of computational capability that is maintained on data centers located across the globe and provisioned for usage as soon as a subscriber or user projects a demand for it. That means the resource is physically not present with the users, but when they ask for it, spontaneously it is made available to them. And if the task is complete and there is no more of a need, the users can just abruptly stop using it and ask for it later when they want to use it again. So essentially, this model is like using a mobile tariff plan. You use it and you pay for how much you have used. You pay for how long you have been using, and when you know the usages, you can even prepay it. And then when you know that your accounts are going low, you can even refill them. So it's a model of plug in and use, and then disconnect after use. So the user pays it for as long as it has used the resources, and the cost incurred is certainly way lesser than the cost of owning and maintaining the hardware for all the purposes. So additionally for on-premises resources, there may be situations like an organization has procured some hardware from some testing, some automation testing, or maybe some performance testing, or any kind of an activity, and then it is used for a 2 weeks of testing cycle. For the rest of the month, which is little more than like 2 weeks, the hardware or the resources are just lying idle and they are not in use, which is again a wastage of bandwidth and capacity, which can be avoided if we use the cloud kind of a setup. So since everything coming from the cloud like this is on a plug and use basis, all the offerings from the cloud, they are called as services. Now, a cloud may offer services at various levels. As you see on the slide, it is just a symbolic diagram of how a cloud is giving away advantages like on-demand self-service, resource pooling, a very, very broad network access. There is rapid elasticity and scalability, and the devices are measured for use. The offerings are certainly in the form of some services, and the services can be at various levels. A cloud may host an application or a software that users use. So that kind of a cloud offering will be called software as a service. A cloud may host an integrated development environment, IDE, or an environment that opens some APIs for a test automation framework that the users can use. In this situation, it is offering them a platform to work on. So it will be called as a platform as a service. Similarly, clouds can even host complete VMs. Like you sign in for the cloud, spin off the VMs and start using it. So organizations do it, and in this situation, they are getting the infrastructure from the cloud, and it term it as infrastructure as a service again. So all these things, whichever are offered from the cloud, they are managed from a portal, which is designed specific to a cloud service provider, and the user can log into that and see the usages he has made and pay accordingly. So additionally, on the basis of security that a cloud can offer, or the basis of the shareability the cloud that a cloud might offer, the clouds are classified again as hybrid clouds, private clouds, and uh, maybe public clouds. So as the name is suggesting, public cloud would be, or let's talk about the private one first. Private cloud would be some data center that is hosted on a cloud, and it is specifically meant for usages by a particular organization. So it is private to that organization, and it's not going to share it with any other organizations. That's a private cloud. On similar terms, a community cloud will be a cloud that is shared by a group of organizations and maintained by one who might be charging the other organization for the usages that they are making. On similar lines, there could be a public cloud which will be open to general public for use. But there are hybrid implementations also, which are kind of combination of a private and a community or a public cloud. In this kind of implementation, an organization can offer something like a cloud hosted a cloud implementation, which is opening things to common public, as in public cloud. Maybe they are giving the capability of creating VMs that anybody can sign up and spin off the VMs and start using it. At the same time, the internal applications of that organization are being hosted on the private portion of that cloud. So this is kind of a hybrid implementation. Um, but the users, they can sign up for the implementation that suits best for them and start using the cloud. So as you see on the screen, different organizations, the cloud service providers, they're working at different levels to offer cloud services as infrastructure or platform or application or software. So let's come back to performance testing. We just saw how typical performance testing procedure looks like. What the components that are used to execute this procedure, essentially it's a tool, but what are the components of such a tool? We have a console with most of the tools, we have a controller, and we have a set of load generators. Now these load generators have the ability to simulate large amount of user load, which mimics the actions that an actual user might be doing. And then we have an application server that will host the applications we actually want to test, and a database server that is running the background for the application. So under this kind of a setup, there are certainly so many reasons why many of the organizations still they are apprehensive, they are hesitant to adopt performance testing as an integral part of their daily activities, their daily QA activities. Although performance testing is important, but there are so many challenges that the organizations see, and that stop them from going and adopting it as a process. So one of them is for sure the hardware and software setup, the tools required, and their upkeeping. When we do a performance test, essentially we need to keep the lab isolated all the time. We don't want unnecessary activities to be performed on the server and impact the performance while we are testing it. So essentially there is a set of high-end machines which will be set aside typically only for performance testing usage, and they will not be used for anything else. So obviously there cannot be shared usage. And then procuring this and setting it up is a cost, and it needs resources, it needs expertise as well. Another thing is about generation of virtual users. All the agents, all the load generators associated with the tools, they are capable of generating load, but certainly there is a restriction on the hardware of the system, which controls the maximum amount of user load that these agents will be able to generate. with typically just for example, typically for a normal machine, a 4 GB machine that we are using I mean daily, that we are using, that machine on a JMeter setup, maybe it is able to simulate 250 users per instance. But all of a sudden we have a requirement in any tool, we have a requirement to generate, say, 700 users or maybe 1000 users. So immediately there will be a need to procure more hardware or assign some hardware to this activity. And this cannot go on proportionately. The more the number of users we want, we cannot just proportionately go on adding the hardware for that. There has to be some scalable solution that doesn't cause so much of a cost. So that again discourages people to go with some specific implementation on premises. Additionally, when we are testing an application from a performance perspective, we are generating load inside the organization. It is using the intranet of the organization, hitting the server, using the application, generating results. But why we were doing performance testing essentially was we want to mimic the real world experience. A real world experience uses the internet, the outside internet. It uses firewalls. It has users that are accessing the application from multiple geographies across the globe. So this kind of simulation is no way happening in an on-premises implementation. There might be a need to look at things from a broader perspective and look for solutions. And there might be a need to execute performance tests multiple times for multiple builds. So this again might not be a very nice way to do with the on-premises implementation. So there are multiple common questions that we get to hear when you talk about performance. It just takes too much time to configure the tool. The site works fine from one location, doesn't work fine from another location, or maybe the test phase is only for 2 months. The boxes remain underutilized for the rest of the duration. So all these things lead us to think of some alternate solutions for performance testing. So this is where we are coming from to look at cloud as a service offering for performance testing. So many of the cloud implementations, as they are offering platforms to work on as service, they are offering softwares to work on, they are offering infrastructures to work on. There is a difference. There is a change in the way the organizations are offering performance testing as solutions. Earlier days, some time back, performance testing tools were sold as a tool. Expertise was sold, consultation was sold. But the current trend is many of the tools, they can be hosted on the cloud and can be used by the organization on a need basis. So that saves them from the extra effort of setting up the performance labs on their premises, and they can just plug in and use like cloud service offerings. So these customers can use the labs on demand and pay for their usage and scalability. So the labs are available on the cloud. So getting into this kind of a setup, there's a series of advantages that we achieve. So this kind of activity saves us from a lot of lab upkeeping, and this is no more a challenge with any organization. Scalable virtual systems are available to host performance lab. Scalable in the sense we were just talking about scalability of the user base. So we wanted the user base to scale up, and there was a need of additional hardware to be plugged in. But here, when I'm using a performance test executing from a cloud, in case I need more of users to use the application or start loading the application, I can just request for it, and on the cloud there will be resources readily available that will plug in, that will join the network of the available computation, and they will start serving for this purpose. So I can scale up to as much as I want, but I'll have to pay for the usage. That's it. Other than that, there is the load can be generated from multiple geographical locations across the globe, which again mimics the real world usage of an application. We know that data centers of the cloud, they are located at multiple geographies. We do not even we cannot even sometimes know. It is so seamless that we cannot know it is coming from such far of a location, because it is so seamless and fast and spontaneous. So we have certainly mimicked the act of putting the load from across the globe. Then, when these kind of solutions are implemented on the cloud, there can be situations where we are even putting our source files on the cloud with some tools. The repositories might be existing there. So, an integration, a continuous integration between builds and performance testing can be achieved eventually, and performance testing can be brought even sooner in the testing life cycle. So these things we are able to easily achieve when we move from an on-premise implementation to a cloud implementation of performance testing. So here I'm just putting forward a summary of the advantages we have just seen about cloud. So with clouds, we are able to achieve the tests that are more realistic than those executed in private data centers, because they come from outside of a data center and they validate other components of the delivery chain, including the firewall, DNS, network equipment, and ISP, which otherwise testing within the premises will not even touch base on. Testing from the cloud also helps to evaluate the real world effects of third party components like ad servers working on the sites, delivery networks, content delivery working on the site, etc. And obviously, we have achieved an infinite computing power because it is available infinitely on demand. There is an inbuilt economic benefit because we pay in an affordable model of pay as we scale up, and then we are saving on the cost of unused hardware and software licenses. It is for sure easy and quick to set up, and the environment is always ready to use. And we are available. Have the ability to simulate multiple geographies. So there is again a list of tools which are offering performance testing from the cloud, like Visual Studio Online by Microsoft. We can create our account. We are provided with an online account portal which we can target and use for the executions. We have others like Sandstorm and from Impetus, Grinder in the cloud. From Swesta, we have Cloud Test. Cloud Test also works in a similar way. It provides us a portal from where we can do recordings and create the test scripts. It gives us tools to install on our local box for an interaction of the application hosted with us with the cloud. So the application hosted with us will be recorded on the cloud with the help of a conductor installed, and it can be played back in that environment. We have browser mode mock, we have Keynote, then we have Storm Runner for HP, and there is a list of other tools also which are available other than this list. So there is a lot of capability coming for this activity in the market, and organizations can certainly look from this perspective and start making use of it wherever it is applicable. So talking about testing performance from the cloud, there are different approaches. These approaches could be, we just saw that there is a list of components that are installed in an on-premise model, which have a recorder, maybe a console, and there is a controller, there is a load generator, then we have application to be tested. When we work in conjugation with the cloud, either we can upload all of this setup to the cloud and start executing the test from there, or we can work in different models, keeping some components on-prem, taking some other components to the cloud. The cloud, a basic straight direct cloud model that you see on the screen is like the recorder lies in the local environment. The scripts recorded here, they are uploaded to a controller that is lying in the cloud. This controller enables load generators and use scripts to work in conjugation and mimic the user activities in a concurrent user environment. And during this process, the load is generated from multiple geographies on demand at no licensing cost. And here, the firewall, in this situation, the application under test is hosted still on premises. There could be firewalls blocking access to it. So we need to work around these firewalls and find out ways how these users will be able to penetrate this and able to access the application. And this is how this kind of an implementation can be done. Another implementation could be hybrid, which is not totally on premises, not totally on the cloud. Here, we record the scripts on premises. Our controller also lies here. We pass the test scripts to the controller. Only the load generation activity is happening on the cloud. So this load generation activity, we are still able to achieve the benefits of simulating from multiple geographies on demand, and we are saving on licensing cost for sure, but we are depending on cloud only for the load generation to attain those benefits. So again, and it is also penetrating to the firewall, so we are able to also test that real world situation. So it entirely depends on which way an organization wants to use the cloud. There might be situations when the organization doesn't have a need to um say large users. It doesn't have a need to test with large users or multiple geographies, but then still it would prefer to go to cloud because it doesn't have a lab existing of its own. It is for sure saving it from the setup costs. Otherwise, there might be organizations which are performing the testing, load testing with fewer number of users on premises. They are going to the cloud only when the user base increases, only for spike testing. So it is not a hard and fast rule that we have to move all of our testing to cloud all the time. We can look for ways that suit best for the organization per se. Having talked about that, there might be, every process has some limitations. There might be limitations. There are challenges with cloud also. Particularly, there can be challenges with data security. Data security in the sense, because we are exposing our internal entities to the world outside. We are not just opening them up, but then there could be security breaches on the cloud, which can access our data, maybe the data that we are using for our test executions. The data is lying on the cloud, and it is more vulnerable for security breaches. So that becomes one of the challenges with cloud performance testing. But this challenge, most of the providers are aware of, and they take very proactive measures to avoid these kind of accidents. So instead of just not using cloud, an organization can rather choose to be very judicious on choosing the cloud provider, maybe that has very strong data security mechanisms. And many times, in many situations, the reason for a security hack might not be the cloud itself. It could be something on the network, it could be something on the firewall that we have taken into consideration in between. So it is not always cloud the culprit. There can be other components in the data chain which can be accordingly narrowed down and resolved. Another challenge with the performance testing on the cloud could be access to intranet applications. There could be some applications residing on-prem, in the sense that there is not even a need to expose them to the outside world, but it could be inaccessible just from outside, and we are unnecessarily doing a firewall breach to test them. So that might be an additional activity, maybe not required or required depending on the organization, but for sure something that is lying inside the on-premise model is not accessible to the things that are running from outside. And there could be a network latency that comes into picture. Like essentially, the user base for internet applications is within the organization, and there is testing it from outside the premises might cause unnecessary network latency. Other than this, there can be one-off situations where organizations might choose to do a performance test in the production environment. maybe in the lean times when the applications are not in use by the actual users. So in such kind of a situation, there is simulated high amount of traffic putting on the server. This traffic can be unintentionally taken as a denial of service attack. That means the load is coming intentionally from some point, which might be some hackers might be doing, but our testing, it is doing an attack that is unintentionally mimicking a denial of service attack. So these things can need to be worked out with operations so that these testings can be performed seamlessly. So there is for sure some additional amount of consideration and work that these kind of testing calls for. But at the end, what we achieve is more realistic test and more scalable tests, which are a need with most of the organizations, which is why they have started thinking on these lines. So having said all that, uh, I would like to talk specifically about one of the tools. I've taken Visual Studio Online, for example. We have a video that will show how we can take the created tests online and execute them on the cloud. So using Visual Studio like other tools. It is quick. It gives us free load testing. It gives 2,000 virtual user minutes every month with no extra cost. It is real-time reporting with charts and graphs. And then again, it is geographically distributed user load, and we can scale up on demand. So same test that we author on premises, we are able to execute those tests on the cloud directly. So on the screen, there is a video where I have a pre-authored web test. It is just talking to a sample application. It's a pre-authored web test. It is talking to a sample application, and it is just a series of login and logout, not much. It is just done to show how we can move to the cloud and execute it. So I'm opening that solution here. This is a typical VSTS environment for load testing. This is the IDE, and here we can create solutions. We can author web tests, and we can create load tests to execute them under multiple user load, concurrent load. So I've already created a solution file here. The general navigation.web test is the file. If you see here, this is a series of recorded steps. Essentially, they are just logging in and logging out, and we have parameterized them to work with multiple users. So this is the list of users we are giving for input. All these 5 users will be working concurrently to log in and log out. That's a very simple, a symbolic load test, I must say. So in order to be able to execute this test the load test from Visual Studio Online, first of all, I created a Visual Studio account, and it offered me a portal, a URL to manage my Visual Studio Online account. Using Visual Studio Online account, I can connect from this portal to the Visual Studio Online account and essentially force my test to run instead of on premises to the URL location. This is the connect icon here. I go there and select a server. I add here the URL of my account, Visual Studio account that I have separately created. So I have a default project created under that, which I'm going to connect now. Now we are connected to Visual Studio Online. Now what we'll do is we'll configure the test settings to force that this test is supposed to be run online and not on premises. These are test settings, and if you see here, I have already by default it is chosen like that. Run these tests using Visual Studio Online. Now I start creating a load test. Now, as I mentioned in the beginning of this discussion, load test is a combination of settings under which we will do the mimicry of user actions. Those settings will be, we just name the load test here. The settings will be around the number of users, the duration, and other things that we want to constrain the script with. I'm just taking 5 users here for simplicity's sake. And I'll add the test that I want to execute, which is general navigation. It is only IE, that Internet Explorer, that we will simulate for now, just for simplicity's sake. And here is where I specify that how long I have to run the test for. I'll just run it for 1 minute for now, and we'll just specify 10 seconds as a warm-up time. So this is where I am able to specify where I want the load to be generated from, which part of the globe. It is giving me an option to select the location. For example's sake, I have taken West Europe, and the test is ready to execute. So this is how the test looks like. And we can go and start executing this test. Now, if you look here, this test is executing online in my Visual Studio account, in my Visual Studio Cloud account. This is not executing on-prem. I would pause here to show that this is showing that this run is expected to use 250 virtual user minutes. So this is what it is consuming from my Visual Studio Online account, because I will have to pay for whatever virtual user minutes I am consuming. I'll be charged for this, and this will be depleted from the account points that I have already. So it's like, just for an example, for Visual Studio, every execution, even if it is not accounting for 250 virtual user minutes, will consume 250 virtual user minutes as the bare minimum quantum of usage. Beyond that, it will be charged as it's scaled up, but a bare minimum of 250 user units are consumed on every execution. It says this test will be run using one agent course. And it was requested by this user of the cloud. It is still under the warm-up duration, which we specified as 10 seconds. After which the actual test will start. So this is the real-time monitoring we were talking about. As the test is progressing, the counters and performance numbers will be plotted on the screen. We got the first plot. We had given the sampling interval as 15 seconds, so it will give me a plot every 15 seconds. We had another dot. So these lines, they are talking about user load, average test time, average page time, processor utilization. Under the other throughput tab, we have some other counters, which are also continuously plotted. User load is the base. We have requests per second, request served, test executed per second, the pages rendered per second, the request served per second. So it was just a 1-minute test for a demo, and now it is collecting results. It's looking like a long time for results collection, but maybe it's relative to the time that we executed the test for. Imagine a test that is executed for 2 hours. This time will look very small. So it gives us a link to download the report, test report. Otherwise, we can select this execution listed here, and there's an option to export the test results. Export test run results. When we export it, it will give us on our local system a snapshot of all this execution along with all the parameters captured during this time frame. So this is how a typical execution on the cloud would look like. So it's not that all the tools will give same steps, but essentially they are simple to execute. They are simple to enroll and execute. And for sure, executing on cloud gives so many benefits. It's not that going to cloud will be able to solve all our problems that we are facing on the on-premises, but certainly it will be able to solve many. And at the end, we'll be able to attain some results that are coming from a real-world mimicry of a test environment. So thank you all for your time. It's time for some questions.
Thank you, Suchita. So that was very interesting and informative. I think there are a number of questions on the chat window. So I think let's start with this one. Sounds very interesting. Would there be a situation where cloud is not able to support a particular type of application? Is the question we have from one of the participants.
Essentially, we cannot narrow down to the cloud not being able to support a particular application. It is about the tool that we are using for performance testing that might not support that kind of an application. Cloud is a concept of shared computing. It depends on the tool that is being hosted on the cloud to serve the application testing. So there can be some tool which is not supporting a particular type of application. We can choose to go with some other tool still hosted on the cloud, and it will be able to support.
Right. So it's more, like we do for, say, automation or functional testing, depending upon testing needs. You have to do an evaluation of a certain tool which serves your purpose. And obviously, once you choose a tool, then you can, use it either on premises or on the cloud, depending upon if they support it or not. Okay. Cool. So I think the next question we have is, how are the units like, as in to measure the cloud usage for the load testing?
Okay, so we just saw that we were talking about virtual user minutes. So essentially, we are talking about the time that we are using the cloud for, and we're talking about the users that the system is scaled up to. So virtual user minutes is a concept of virtual users working for some amount of time. For example, I'm using 20 users to hit my application. And then 20 users, I run a test. With these 20 users, I run a test for 10 minutes. So I have consumed 20 multiplied by 10, 200 virtual user minutes, which will be deducted from my online account. So this is how the billing happens.
Okay, excellent. So I think we've got one more question here. I think if you have to do performance tests very often, is it suggested to use cloud?
It may be and it may not be, because going to the cloud very often may call for a very often expenditure on plug-in use in the plug-in use model also. But then we have to evaluate what is the user base we have to scale up to. If the user base is so big that we need so much of hardware to serve to be able to achieve that, we may prefer to go with cloud. Or if the user base is not that big, we can procure some couple of machines can serve our purpose. We can stick to on-premises.
Okay, excellent. I think we don't have much time left, but let's take one last question, and I think then we can close it.
So there's another question. It says, is there a limit in terms of concurrent and simultaneous users while leveraging cloud? And what are the typical monitoring challenges while we are testing in the cloud? So as we said, it is scalable. So we can reach to very, very high spikes, like maybe 70,000 or even 80,000, even more than that, depending upon our application and the kind of cloud hosting we are using. From the monitoring perspective, we can monitor many aspects of the application, but we might not be able to see precisely as to how much of a resource crunch has been created, because resources mostly will be available on demand for load generation at least. And otherwise, from the application perspective, we can still continue to monitor the application providers in the application hosting systems. We can still continue to monitor.
Okay, excellent. Thank you, Suchita. So I think this is all we have time for today. That said, these are monthly and recurring webinars. So look forward to see you guys again next month. Thanks for joining. Bye for now.